This is Greg Troutwine. I'm with Marine Technology TV. We're here at the Oceanology International in San Diego, and we're here with Andy Hughes of Silicon Sensing. And first and foremost, Andy, thanks for joining us.
Thanks, Greg. I appreciate being here.
Absolutely. Well, Andy, I know we've written about your company many times in the magazine, but for our viewers and readers who might not know who Silicon Sensing is, can you just give us an overview of the company?
Sure. Silicon Sensing is a very interesting joint venture company. It's half-owned nowadays by UTC Aerospace Systems in the US and another company called Sumitomo Precision Products in Japan. We're centered in Plymouth, England. That's where our headquarters is. We split the world geographically by time zone in terms of our sales force. And we're a very effective joint venture because we combine the complementary skills of the UK side and the Japanese side, the designing of the product, and then the very precise Kaizen-based manufacturing techniques at our foundry, which I'll tell you more about in Japan.
Okay. So tell me a bit about the foundry in Japan now. That you've whetted my appetite. That's excellent.
Well, Silicon Sensing makes gyroscopes.
Okay.
Now, traditionally, and going back 100 years, back to the days of Elmer Sperry, gyroscopes were large spinning devices which told you about rotation. Okay. Now, gyroscopes today, through Silicon Sensing, still do exactly that in that they tell you about rotation. Okay. But there's been some massive movement in the technology away from rotating gyroscopes for very specific reasons into silicon MEMS construction. Okay. Now, that's hard to take in. It's a wafer-based technique in which you mechanically etch away silicon until you're left with a ring. Okay. And the way to think about that ring is like the top of a wine glass. You imagine giving a wine glass a ting and it vibrates, it sings. Essentially then, if you were to twist the stem of that wine glass, you would experience a change to the vibrating pattern. Okay. Now, translate that into silicon MEMS with the deposition of electric tracks on it, and you can actually both set up the resonance of this device, make it sing the whole time that it's powered up, and then you can actually detect rotation, providing the same sorts of outputs as a gyroscope did 100 years ago, but in something the size of your little fingernail, and in fact, I have one here. This is a typical sensor head, the core of our silicon gyro technology. Inside, like I said, there's a silicon ring, which is surrounded in this case by a magnet, and there's a small amount of electronics as well. And that is the heart of everything that we make now.
Where do you see opportunity? And I'm assuming you see a lot of opportunity.
What we've been doing since Silicon Sensing was set up, which is about 20 years ago, is first of all, we were attacking the high-volume automotive markets. We were the first to bring commercial silicon gyro technology into a price zone where it was suitable for the birth of advanced braking systems, which would actually manage your impending skid and do something about it, something which is now mandated for all cars. And at that time, 15 years ago, we were selling 3 million of these gyros per year. We were the first to market. We were very respected because of our robustness over rough terrain, and we did very well from it. After that, there inevitably became a time when competition started to catch up. And essentially, to cut a slightly long story short, the sorts of gyroscopes that you now have in your mobile phone, which cost pennies, are actually adequate for that automotive technology. Whereas the particular construction of MEMS that we use, which is unique to Silicon Sensing, is capable of far higher performance. So what we've been doing once we moved away from the difficult competition in automotive is to grow ourselves up the performance capability. And of recent times, we've now developed not just single-axis gyros, but complete what are called inertial measurement units, which mimic the performance of fiber optic gyros. Now, fiber optic gyros are well known in this particular market here today because they provide the level of sophistication that's needed to navigate a remote operated vehicle, to stabilize a craft with adequate performance. But they're very expensive. This product is typically 2 to 4 times less pricey than fiber optic. So it's very attractive, and it retains all the advantages I previously mentioned about robustness and everything else.
When we were discussing before, you noted that there's a significant anniversary coming up in 2020, specifically the Mayflower 400. Can you tell us about that interesting project as well as your participation in it?
Well, first of all, the Mayflower 400 celebrations is a growing development of planned activities by Plymouth, UK, which, if you remember, is where our company is based, and Plymouth, Massachusetts. And the pull together of those two cities is, of course, because of the Pilgrim Fathers, who started their journey across from Plymouth, UK to Plymouth, Massachusetts. And there is a great desire to pull together a whole set of activities to commemorate this 400th anniversary. And that's going on at council level between the two countries, and there's a growing menu of events that will happen. But what's happened that's of particular interest to us is that a consortium of a number of companies, some based in the Plymouth area, have got together and decided that they plan to commemorate this event by creating an autonomous ship, the Mayflower autonomous ship. And this, in September 2020, is going to sail from Plymouth to Plymouth completely autonomously. It will follow a route that has been planned on the land, but all its local decisions will be based on internal artificial intelligence, using the sensors on board, using the control, managing the sails, managing the weather, and navigating itself from one point to the other.
So what specifically is Silicon Sensing's involvement in this project?
Right, well, because we feel very close to this because of where we come from and our relationship with high technology, Silicon Sensing is a major sponsor of the event. The MAS 400, as is known, has gathered funding through crowdfunding, through major sponsor input, and through the prime members of the consortium offering their particular skills, like the shipbuilding, like the control, and so on. We are not involved in those design decisions, but what we are doing, apart from sponsoring, is offering our specific technology, which, just like for customers here today, is going to form the heart of that navigation solution, doing the sensing, working out what the ship is doing in order to complete the control loop of actuation and control and more sensing to make sure that the ship is correctly powered, pointing in the right direction, and doing everything that it needs to get from point A to point B.
Again, Andy, very informative, and I truly appreciate your time. Hope you have a great show, and thank you for joining us.
We're enjoying ourselves here. It's a great city, and we're excited about the opportunities.
This is Greg Troutwine with Marine Technology TV.